In this video, we'll talk about dyadic product or tensor product. And therefore, how do we talk about this? For this, I will just go back to the concept that we have derived previously. Alright, this is a directional vector, or not vector but rather a directional space. Alright, this is the basis vectors E2, E1, alright, E3, if you still remember, with magnitudes 1. Alright, or you can simply write them as EI hat, right, in the I space. Now let's take a look in terms of 2D, because 3D is a little bit too much for me. So in this case, let's look into 2D. This is also another space I will look at. I'll call this K. Alright, and then the basis vector for this space K is E1, I call this E2 hat. Okay, this is E1 hat. Alright, each of them also have one magnitude. Alright, so to be that. Now, okay, let's remove this. Alright, I'll not do upon this, I'll just do upon this. Alright, this is one space in the K space. I'll just now write this in the perhaps the J space. Alright, so this this basis vector and this basis vector are different. Alright, they are in the different space. Alright, if I were to do certain magic, alright, if this is the case, because I can write this as EK hat, right, I can write this as EJ hat. So J can be 1 or 2 or 3, K can be 1 or 2 or 3, depends on whatever you want. Alright, so EK hat, dyadic product, EJ hat. This is what we are talking about. Alright, and this is the reason behind many understandings of the how many 3 times 3 bases, like 1, 2, 3. How this acts as a building block. Okay, so for example, if you put in numbers 5, 4, 2, 1, 0, 3, etc. Alright, the dyadic product itself some sort of give us the 1 1 1 1 1 1 1 1 type of thing. Alright, but I'll just not go into 3 times 3 matrix. I'll just go into 2 times 2. At least you know what the dyadic meaning is all about. Alright, so imagine I have, alright, E1 dyadic, E1. So when K is equals to 1, J is equals to 1, what we have? We will have 1 0. Alright, if we're talking about in terms of 2D, we have 1 0. Alright, so in other words, we have E1 hat. Alright, perhaps we can say that the dyadic product is simply, alright, EJ, right, maybe E is equals to EJ hat multiplied by EK hat transpose. Alright, in a certain meaning. Alright, this is just that perspective. So if I were to do that, I have a matrix of 1 0 0 0. Now I spend the next one, E1 E2. Now J is 2. Alright, I would have 1 0 0 1 in this case. Alright, because now E2 is, so this is E1, this is E2. Alright, so E2 is times 1, E1, there's no E1 anymore. E1 in the K, in the J axis. So J axis is only just 2, that's all. Alright. But in other words, this E1, alright, is simply talking about this. Alright, this E2 is simply talking about this. Okay, hope that this is pretty much clear. Alright, so this 1 is for this thing. Alright, so this is like E1 E2. Alright, this is another E1 E2. Alright, this is in the J space, this is in the K space. Right, so this is simply this one is simply this one. So the objective that I want to convey is that if you have 1 or 2 or 3, right? For example, if it's E3 in this case, then I'll have 0, 0, 1, something like that. Alright? So now it's E2, then I have 0, 1. Alright? So but nonetheless, when I do this, I have 0, 1, 0, 0. That's the meaning of that. Alright, if I were to continue to do up the matrices, alright, if I have E2 hat and then E22, what I have been taking on is actually taking on all this stuffs. So in other words, this is E11 is talking about this thing, E12 talk about this thing, E13 talk about this thing, E14 talk about this thing. So do you find it very familiar? So you are just simply building up the blocks for a matrix using the basis vector. Alright, this is in terms of the 2D. Alright, if it's 3D, then I have more things to write, but I just want to convey the concept. So in terms of 2D, this can suffice the concept. Now, for example, we know that the components, alright, the components is simply, let's say for example, we have I call this a vector. Alright, the component is simply, if I were to extend this thing, alright, simply, because this is magnitude 1, alright, it's simply, maybe this is 2, this is 3, alright, so it's, in the x direction, we have 3 E1 hat, alright, so it's 3 times E1 hat plus, perhaps this is just 1, okay, so I have plus E2 hat, 1 E2 hat. So the component itself is 3, 1 with E1 hat plus E2 hat. Sorry, it should be like this, alright. So the components is being written over here, 3, 1, and E1 is the basis vector. So the components are just in terms of the basis vector. Alright, how many times the basis vector? So how do we use this concept to illustrate on certain stuff? Alright, so I just want you to know this concept first for the dyadic portion. Alright, this is the portion that I want to convey. In terms of the basis vector, now we're going to include the components. Alright, now we're going to add in the components. So the components itself have A dyadic product B, where AI, alright, so A itself has A1, A2, A3, alright, and is invisibly, alright, invisibly there is E1 hat, E2 hat, and E3 hat inside. Okay, so in other words, we have A1, E1 hat plus A2, E2 hat plus A3, E3 hat inside this AI. Alright, so I just want to make things pretty simple for this case. Alright, so now the next step is AI EI hat, since we know that we can simply write things in terms of A1 E1 hat plus A2 E2 hat. Right, so these are the I's. Right, so we can just write a general equation to represent those in terms of this thing. Alright, is BJ EJ hat. So A dyadic B is written in this form, can be written in this form also. Alright, and therefore what I gotta do next is, we know that EI and EJ are the basis vector, so we can put the basis vector together one set, and we know that the basis vector controls everything. Alright, this is the key concept I want to convey also, is that the basis vector controls everything. The components is just some constants. If you remember back to our this example with my right, this A bar, right, this vector A is comprises of how many times you multiply with the basis vector. Alright, so this 3 is actually a component. Right, it's just a multiplication, it's just a constant scalar. So I can just simply write as AI BJ. Alright, and EI dyadic EJ is simply what we have said earlier in this form. It's just to create a platform. In this 2 to 2 thing is just 1 1 1 1. Alright, with each component they can just sub it into here. Alright, so depending on which component you're talking about. Alright, so therefore this set as a somewhat a deep meaning into why is it 3 times 3 or 2 times 2. So the dyadic product is simply somewhat doing that manner. Alright, and therefore AIBJ is simply some constant value. So if it's some constant value, I can just write as WIJ, where WIJ is the components for the EI dyadic EJ. Alright, which often we will just write as WIJ, and then the matrix 3 times 3. So the 3 times 3 is simply based on these things. Alright, this is somewhat of the meaning of the abstract meaning of the dyadic product. Alright, but before I end this video, I just want to do some exercises, so at least it's better. For example, if I have a matrix Tij Vk, the dyadic product itself, we can just write as Tij from the previous one as we have just derived. Wij can be rewritten as Wij with the dyadic products over here. Alright, so we can just simply write as Tij and then bracket Ei hat dyadic Ej hat. Alright, and then we can dyadic product with actually this should be dyadic. I actually forgot to write. So this is dyadic. So the question itself is Tij in the matrix dyadic product with a Vk. I actually forgot to write that shit. Anyway, so in this case Ek hat. Alright, now I can just sum the constant back with them. So I have Vij, Tij Vk, then I will just simply write the dyadic product in terms of their basis vector. So this is the components, these are the basis vector or the dyadic. The basis vector controls the dyadic things. Alright, and therefore the next understanding, if I have you have Tij dyadic product with URS. Alright, so what is it? So to start off, same thing, Tij is equals to Tij multiplied with Ei dyadic with Ej. Alright, then I dyadic product with URS, where URS is also equals to Er hat dyadic Es hat. Alright, and then I rearrange the constant. I bring the constants together as here. Alright, and then I just dyadic all the products. Alright, and this is the form in terms of all the basis vector. This is the form in terms of all the components or the scalars. Alright, so for higher orders, if let's say what I mean is Tijk and then dyadic with U, R, S, P, alright, you'll do the same thing. Alright, so this is just the concept of how to apply. Alright, so this is just the dyadic product of so this is the understanding. Alright, and the key takeaway is dyadic product represents these matrices over here. Alright, so it somewhat builds up your matrices, and that's all. Next video, cross product.